What's up, guys? My name is Mark, and what are we doing here on this channel? We are building for next billion users, and I'm Fancy developer. And this T-shirt, this very T-shirt you've seen so much on these videos, I got from Shahar. Hi, Shahar. So Shahar is a very cool guy from Orbs team, and you can introduce yourself as well.
Yeah, sure. Yeah, so as I said, I work at Orbs. We do a lot of things on blockchains, and recently we've done a lot of investment on Ton specifically. We're excited about the next billion users, as you are. Personally, I led the development of the Minter tool, which is what you use to deploy altcoins on Ton, similar to ERC20s on Ethereum. And it is now an official Ton Foundation tool. And the latest thing which we're going to talk about today is the verifier tool, which is used to verify smart contract code on Ton.
And you're also the leader of this project, right? Or
Yeah,
okay,
yeah,
nice, nice. Yeah, this is interesting. I had a very deep and interesting conversation with Talcol, and you guys are mates as far as I know, right? So
yeah. We work together. Yeah.
nice, nice. So and there's an interesting problematic that he stated out on the interview. By the way, guys, if the interview is already out, you will see the link here on the top. So you should definitely watch it because the problematic, like long story short, what he was talking about is that when you're sending like 2-3 tons, then it's fine for you. Like you just trust the developer who is like probably not scammed because everyone is sending him. So I'm gonna send and it's gonna be fine. But once you're a fund and you're about to send some big funds, I don't know, like $1 million worth of ton, you're gonna send it into the contract. Even if it's your developers, you want someone to be able to audit it and not for the source code, but there must be some way for you to understand if the source code and the actual address are doing the same thing that they state to do, you know? And as Tal Cole states that in this interview is that this is one of the holders from the mass adoption. Like this is one of the holders that is not allowing big funds to put the big money and being able to bring this trustless, bring it to the masses, you know. So I believe like is that something we're going to talk about today?
Yeah, definitely. This whole project, it starts with a TEP, tone improvement suggestion that discusses how decentralized verification solution would work. The thing is with Ethereum, for example, that you do have the source code there on Etherscan, but the solution is completely centralized. So Etherscan is holding all the source code and displays it to you as the user. So when you want to interact with this contract, you have to trust fully that what you're seeing is in fact the verified source code. So when large amounts of money are involved, the incentives to do malicious things also grow. So, who's to say that you're not viewing a source code that has been modified in some way and only has the green check mark there, right?
Mhm.
So that's one aspect of it. The other one being that the entire source code is, saved somewhere in a centralized storage that you can't scrape or clone or whatever.
Mhm.
So it doesn't really belong to the community. So the smart contracts are open there on the open blockchain, but you don't really own the source code for them. So that is one thing that we wanted to solve. So I think it's important to say that while some of the solution that we've rolled out is powered by Orbs in a way, it already doesn't rely on Orbs infrastructure fully. And the most important part of it is that any party can join as a verifier without anyone being able to put some censorship on top of it. So any group large enough in Ton that's interested can just join and verify source codes in parallel to the Orbs verifier that already exists.
Okay.
So the solution is completely decentralized. and we'll go into detail how.
Interesting, interesting. But I believe we can start just with code, like by the way, sometimes I'm asked like, where's the code stored? And it's like it it's a simple question. I can simply say it's like inside of the like TVM memory. Like the code is like it's inside of the cell, but um, basically where is it stored before it gets into the TVM? So it's just how to answer the question properly.
So, if you think about the blockchain as decentralized storage solution, which is what it is at the end. So the code is represented as a cell, exactly as the data for the contract. So the contract has two parts. It has the code and the data cells, and the code is just stored there and is loaded to the TVM in memory as needed.
Okay, okay. So that I will probably just reference that like the code is stored same as data. So
Yeah.
because some people expect some difference in how they're stored.
No, yeah, it is exactly the same in that sense that it's represented as a cell. When you deploy a contract, you provide it as what is called what is known as a state init, which is just an object containing both initial data, which
Mhm.
is a cell, and the code, which is a different cell.
Okay, cool.
So yeah, that part is crucial for the verification process because the way you distinguish one contract from another is by the resulting hash of the code cell. So each cell in Ton has a hash function, which corresponds to what is known as the cell representation. That's discussed somewhere, I think, in the TVM white paper,
Mhm.
which is a hash representation of the cell. So, for example, if I have a wallet V3 R2 and you have them, they would both share the same code cell hash because it's the same, they have the same code cell stored, correct?
Mhm.
So what we want to do is to be able to view the source code per each code cell hash that exists. That's what we're looking to achieve here. So I want to discuss a little bit about again why we want to verify it to begin with. Why is it an important thing? So I think we started kind of in the middle talking about why if you have a centralized verification solution such as in Etherscan that might cause problems, but basically when you think about it, if you're dealing with large sums of money, you want to be able to view the source code. You want to maybe put a team of technical people on it and know what you're dealing with. You want to know that if you're depositing money into the contract that you will be able to get it out. You want to know if someone has the ability to change the code of the contract. You want to be aware of that. That's a risk. If the admin can be changed, if the admin is present or not. So some contracts you expect them to revoke their admin and just put it on a zero address or something similar. Um, if the admin has the power to withdraw all the money staked in the contract. So these are very important things when you want to deal with large sums of money that will allow you to avoid rug pulls and other malicious patterns
And
that
I
may.
believe it's like it's helpful for the risk management because like there's a certain level of risks for each of the things that you just listed, right? And I believe when people want to throw a big amount of money, they want to at least measure some risks like, okay, this contract is able to do that, but what
Exactly.
kind of risk does it bring us, you know? And that's what
Exactly.
you guys used to do, yeah.
And I think, one of the interesting things that we see that some explorers, they tell you things about the contract. So they tell you, this contract can replace its code. It has like the set code directive somewhere inside it.
Mhm.
Because, you can figure it out from the disassembled code, which is very hard to read. But if you do some kind of processing on it, you can extract some kind of insight such as that. Some explorers will show you that this is a wallet V3 R2 wallet, contract, sorry. Um, And that's problematic again, because you have to trust the explorer to be showing you, the correct data. You don't know for yourself as the user. So this is one pattern that exists today. The other is just sending you to a GitHub. And that's interesting. Someone tells you, okay, this is the contract. So you have something on chain, and this is the code for it, which is in GitHub. So, we've come across many examples where the code in GitHub was updated, but the code on chain wasn't. So what you're actually seeing is not the actual code, but you would think that it is, because the developer had good intentions. It just made like a small modification or a fix, which
Maybe.
may not be critical to him, but it results in a completely different code cell hash. So you don't really have that certainty that you're dealing with the same thing. So that's important, because we're not always on the happy path. Some developers may use that and tell you, okay, that's the source code right there in GitHub, but in reality, it does something else completely. So that part is important to understand. So other things I'm seeing which are nice is that recently Tonekeeper has rolled out like a simulation for transactions. So if you issue a transaction which results in other transactions being made on the chain, especially since Ton is asynchronous, this is important. Then you see like a simulation that tells you whether some GTONs are gonna be sent somewhere, or whether you're gonna be refunded and things like that. That is important too, because it emulates the TVM probably on their backend, and tells you what's gonna happen. And the wallet is the trusted entity anyway, because you provide it with your seed. So that's okay. I think it's complementary to being able to view the source code itself.
This is kind of cool. I didn't hear about that simulation. I might want to dig into that after. So I maybe also record video with them, because this is one of the very good ways to give this sense of security to the guys.
Yeah, definitely.
The access, I see like a list of, like, my mind is just thinking about the use cases, and thanks for putting it out.
Yeah, this is important, and we're also working with some teams that develop the development tools in Ton to be able to do these kinds of simulation when developing the smart contract, like issuing out all outstanding messages. That's gonna be the result of sending a certain message to the first contract, etc. Okay, so hopefully we've based that it's important to view the source code now. And now maybe the question is how. So I want to maybe share my screen and show some things.
This will be great when we make a post. All right. I believe now you can share screen.
Okay, good.
Yeah, I can see a screen. Great.
Good. So let's start with this. So this is the tip, okay, that we've proposed, that deals with decentralized infrastructure for verifying Ton smart contracts. There's a lot of things here about the motivation on why we're doing this, and so forth, that we've somewhat discussed already. And what I want to discuss is the main architecture. Okay.
Okay, cool.
So one party that we have here is the verify registry. The verify registry is a somewhat generic contract. It does not necessarily deal only with source code verification. What it does is allows a party to stake a certain amount of Ton. And by staking that amount, it gets the right to store its configuration in the registry. Configuration says how many endpoints does it have and what is the public key for each of those.
Okay.
And once you specify that, it allows the verifier registry to know whether to forward messages on these verifiers' behalf. So it's essentially, you can think about it as a multi-sig wallet in a sense that works with internal messages instead of external messages. And it's a building block in this process, because in the source code verification process, because what we want in order to be decentralized, we want to enable verifiers to have more than one verifying node. So a certain flow would be that you would ask the verifying node to confirm that a certain set of source code indeed compiles to the same code cell hash as you see on chain. And then you gather more signatures from more endpoints, and the verifier registry would ensure the authenticity of those. So it does the signature matching, and it also checks that it has enough signatures according to the config, which is the quorum. I mean, if you have, like, for example, 10 nodes, but you only need 5 of those to let the verifier registry pass on the message, then you need to collect 5 signatures in that sense.
So
So
this verifier registry. So basically, if I want, so one verifier registry is hosted for one verified contract, right? Or is it like?
so no, there's like a single instance. There's a single verifier registry. And think about it that we have 2 teams, okay, your team and my team, in the Ton ecosystem generally. And I put on a verifier, okay? So that my verifier is an entity that verifies source codes. And I publish it with 10 nodes because I want it to be even more decentralized. And I require that 5 of those confirm that the source code computes to the the code cell hash in question. And you want to become a verifier as well, so that not the entire ecosystem is reliant upon me, because I could compromise all my 5 nodes maybe, or all my 10 nodes. So you stake the amount, let's say 1,000 or 10K ton into the contract, and that essentially only registers you. So if people trust, you and me, they just read any verification that would result from sending message to this contract from either of us or both of us. And that way you can, you can make it more decentralized in the sense that you have multiple verifiers on the network. I will show a diagram about that in a second once we like do. Yeah, because it's a fairly complicated architecture. But again, I want to finish with the bottom line. You can think about the verifier registry contract as a multi-sig wallet that has different parties. Okay, it like holds the keys for different entities. So the verifier registry job here would be to pass on messages after verification, obviously, to the sources registry contract. And the sources registry contract is like a JSON minter. It's a sharded architecture where the combination of the verifier ID and the code cell hash, it tells you which address would the resulting source item contract would have. So let me share the diagram. Maybe we can make it a bit more clear. Oh, sorry. Let's make it a bit more. Okay. So let's discuss first the verification process, okay? So the first thing is that we offer like a DApp to verify the contract. And that DApp provides in step one here, it provides the backend. So it could be Orbs backend, for example. It provides it with the source code and the hash it claims or it tries to verify. The backend, what it does is compiles this source code and sees what is the resulting code cell hash. If there is a match, it uploads it to IPFS, a JSON which describes the sources and the compilation and also the sources themselves, and brings back a signed message with the private key that's stored in the backend to the client. So if the client, if the verifier registry for this verifier ID has a multi-sig quorum of, let's say, 2 nodes, the client now needs to approach a different backend and provide it with the signed message and ask it to sign it too. So at that point, the other backend does the same process, hopefully resulting in the same code cell hash and adds its signature on top. And now, great, the client has 2 signatures. It can publish it to the verifier registry contract, which knows what is the configuration for this verifier ID. So in this case, it verifies that the signatures match the public keys it's aware of, and also that we have enough signatures, which is 2 at that point. Otherwise, it drops the message, but in the happy path, it just forwards them to the sources registry contract. Now, the sources registry contract knows that any message that it gets from the verifier registry is already authenticated. So it only checks whether the message actually was received from the verifier registry contract. And if it does, it deploys a source item contract. Okay? And the source item contract only needs to contain the link to the JSON in the IPFS. That's its job. So this is what the verification process looks like. Now, any party that wants to show verified source code now asks the sources registry contract, can you tell me, please, what is the address if I'm looking to view a verification done by orbs.com, for example, for the code cell hash, this and that. And then the sources registry contract gives him the contract, and it can tell whether, if the source item contract is deployed for this address, it can tell that there is a verified source code on the chain. So what is important here, if you notice that once the contract is verified, there is no real Orbs infrastructure or any party infrastructure for that matter that you need in order to verify, to view the source code, because it's either on chain, the pointer to IPFS is completely on chain, and IPFS is IPFS. I mean, it's decentralized by nature. Anyone can pin this source code. So that was one thing that was very important to us in the design of the solution, that the source code wouldn't belong to us, but to any party.
And I very much like it that it doesn't work like in the real time. It's not verifying every time someone wants it to see it verified, because I was thinking by myself about the ways to verify it, and my ways were quite simple, but not that stable though. But this acts like some kind of a certification, So basically, once your contract is certified, like basically you have, if you are on the sources registry contract, that like you are fine. That means that you actually, there was a check before. That check happened. Not just everyone says yes, he's fine, but every party has to actually compile it and provide it with a signature. So it's much more complicated to kind of fake. Like it's way more complicated, and we actually already have a proof of verification every time we want it. And the cool part is that we can actually, like just you said, like I'm just absorbing it and like getting on track.
Yeah,
We can show the source code every time someone is asking it, and we're not taking it from GitHub. I think this is just brilliant.
exactly. Exactly. That's the important part. And one thing I want to emphasize here again, because we see here like the block explorer,
Mhm,
let's say Tonscan is asking for the verified source code,
mhm,
and it has to specify the verifier. So it can do one of two things. One is to query the verifier registry contract for all verifiers,
mhm,
just do a kind of iteration on that. And then what you would do is to ask again, for another one, okay, which isn't Orbs.
mhm.
And this part is important. So the way we actually think that this would work is that probably there will be maybe an allow list or a block list, because if things get hotter in the ecosystem and you have someone actually trying to fake the source code, there might be a case when you say, okay, I don't trust Orbs anymore. I don't want to view any verifications done by Orbs because I caught them trying to fake the source code. So then in that case, all you need to do is just put them in a block list, and then you start querying only the other verifiers. And when you do that, you've completely eliminated, the party who created the solution, which is us, and the solution can live on. Because again, it's completely on chain and you put the storage wherever you want.
Mhm.
Um, of course, this will be upgraded to ton storage when it comes out.
Very
Uh,
soon, very soon.
yeah, so this is another thing that there's an upgrade path for all these contracts in case it's needed. But again, the multi-verifier architecture is even more important than the multiple backends per verifier. Uh, Hopefully that's clear.
Yeah. This part is clear, and this is what makes it so certification like. I mean, what I mean by certification is like you get a how you sign the apps that you publish to the app store. Like you receive certain provisioning profile, and at the end you have a proof of verification. This is what I really like here.
Yeah. So one question that we get sometimes is, you're able to verify the contract today within the browser because you have the WASM compiler. So it's not that hard to verify a contract in a sense, right?
Mhm.
But I think still that if we didn't have this kind of architecture and we just let anyone publish a verification, however he wants, to some kind of repository, I don't know, even to make the transaction directly to the sources registry contract, because you say, okay, in case someone publishes, sorry, a fake source code,
Mhm.
then users will be easily able to re-verify it on the browser and know. So that's correct, but I don't think we would want an ecosystem where you approach the block explorers that shows you the source code with such low level of trust. Because if anyone can do it, there's no trust at all. So you would just hit the re-verification button all the time, um, and you would maybe kind of expect even the contract source code not to be the correct one. So I think it's important to put a gatekeeper that's much harder to cheat. So that way you'd know that if anything goes wrong, it's on the verifier side, and you just eliminate that verifier. You put it on a block list altogether, instead of, I would say, compromising the authenticity of what you see on block explorers. So I think being able to re-verify in the client is very important, but not everyone would do that. And again, we want source code viewers that we see on Block Explorer to be worth something. So that's my take on it.
Nice, nice. And what's the status of this TP? Like, is it already merged, like in progress?
No, actually, the TP itself isn't merged, though we have worked closely with the core team of Ton to verify, almost all known contracts and the
Mhm.
important ones in the ecosystem. So what I do want to show is that the solution itself already exists. So what you have, for example, um,
Oh, nice. Don't
yeah,
verifiable.
so we have done verified that live, which we just announced.
Yeah, we're
Um,
gonna leave the link in description, so you guys should definitely hit it.
yeah, and what you have here is an example for a verified contract. So again, same architecture. It uses an SDK that we offer all explorers and any DApp wishing to show verified source code to query the chain uh, um, for the verified source code for this code cell hash. Okay, so we have a contract here that has its address on ton and the code cell hash. As we said, many contracts can share the same code and therefore the same code cell hash.
Mhm.
And now you get a few things. One of them is which compiler was it compiled with, which version, which is important because there can be differences in the resulting code cell between versions, and also what you need in terms of files in order to compile this contract. So that is one thing. The other is the source code itself, obviously. So this is the config code, which is one of the core contracts on Ton.
Mhm.
For example, it doesn't match the one on GitHub. We had to go like a few versions back in order to verify it.
Okay.
So this is, or I would say, this is not. I'll go into that later. What we have here is that what we can say about this code is that it compiles to the same code cell hash on chain.
Mhm.
Okay.
This is the state of code at the moment and how it's going to stay with this address. And I like it's connected to the address on the verifier place, not to the GitHub where people, the guys can just remove comments and it will have the different.
Yeah, we'll talk about the comments in a little while because it's an interesting topic. But what you know is that this, whatever is the resulting bytecode of this code
Mhm.
is what you have on chain. I'm using like very careful sentencing here because um, you can change some things and still achieve the same code cell hash. So you still need to be careful. Okay, but it's obviously better than dealing with these kind of things because this is the disassembled code, which
Yeah.
you know it has like I don't know almost 2K lines, and nobody would be able to
Well,
read
thanks
it.
God we have Fancy. Like the moment you come to Ton and you start learning Fancy, like you have seen me encountering Fancy like first times,
Yeah,
and since then I have to say I have grew up. I've learned a lot, but then you see the disassembled code and you're like, okay, Fancy is cool. Fancy is nice.
yeah,
It's
yeah.
not that hard actually.
It's obviously better.
Yeah.
So this is one thing. So the verifier is mostly meant to verify code, not to view it. The viewing part is
Mhm.
it belongs in the Explorer. So we already have an integration with Tonscan, which is I think maybe the largest Explorer.
Mhm.
So if we go here, note two things. One, it already tells me that this is the config. This is the part that you could consider as, centralized. I mean, the Explorer is telling me that because they've named this contract. They have like a map somewhere that says, okay, this address, this is its name. You have to trust them. So obviously we do at this point, but it's something to consider. Um, and the other part, which is coming from the decentralized solution, is the source code, which is exactly the same because it's being taken from the source code registry, as we've discussed. So
Mhm.
same thing, only that you view it within the block explorer.
Oh,
So any verified contract, that's verified on ton verifier and by proxy on the sources registry will be shown here in ton scan.
Okay.
So this is I think something that we feel is an important contribution to the ecosystem, because now you have a block explorer on which you can see all verified code.
Yeah, and is it already now like the tone scan is working the way you showed me on the diagram? So they're actually asking the um like the actual contract, the source code registry.
Yeah.
Okay, okay.
There's only one verifying party, which is orbs.com.
Mhm.
But once we have more, we're already in discussions with some of the teams about that. Then they will query, they would query more than one, and any mismatch would just arise.
What does it take to become a verifier?
So I guess a few things. One is to stake a certain amount in the verifier registry contract, like you reserve your place there, okay? Because we want it as a gatekeeper for spam. So that's one thing. The other thing is once you have that entry in the verifier registry, you can pass in messages to the sources registry contract, and then you need to verify contract somehow. So it all depends, on how you do that. You can do that like in the back end.
Mhm.
Maybe you monitor whatever contracts are verified, by another party, such as us, and you just do a re-verification on top of that.
Mhm.
And once you do, so I guess what once you do is you just ask all explorers to add you as another verifier on the list that they query.
Mhm.
So I would divide it in two. You can become a verifier on your own, no censorship or anything whatsoever. And to get the product such as the block explorers to use your verifications, you need to ask them at the moment.
Mhm. Okay.
All right.
Yeah, wow, man. Like it's so interesting. I mean, that's very like that's a lot of the big piece of information. It so slowly I'm getting into it and I like it so much.
Cool.
Like this is very sustainable model of providing like this trust, like managed trustless solution. But it can't be called trustless yet, I believe. But we on purpose keep the gatekeepers, right? To not pull all the pressure on the explorers. Like
Yeah, exactly. We have the gatekeepers, but again, it's decentralized enough so that any verifier can be, replaced. If we don't trust a certain verifier, we just can replace him, and all the explorers would comply. And the ecosystem is not dependent upon any specific party. That's the important part here.
mhm.
Um,
I
okay.
you've mentioned before about the set code things. Like,
Yeah.
is it not the right time yet? Because I'm very curious about how set code is going to get into play.
Okay, so what I want to touch upon now is what affects the code cell hash. Okay, so I'll give like a hint. I mean, if you set the code of a certain contract that allows you to do it, the resulting code cell hash would be different. And then you just hit refresh here on this page and you don't see the code anymore, right? Because we don't have a verification for that.
Mm,
So that's what's going to happen if you set the code. But there are other things that we need to consider when viewing verified code and verifying code by ourselves. So I want to demonstrate. Maybe we do like a very small workshop.
nice, nice.
Um,
This would be cool.
okay. So what I've here is the Ton starter contracts, which is a template for developing fancy contracts. Maybe you can link to that later in the channel.
Okay, I will. I will.
And what I want to show is this. I have the contract at the moment. Maybe Just list everything here.
Mhm.
And I want to output the code cell. Let's see if we have it. Okay, I want to output the code cell hash. So cell artifact, sorry. All right, yeah. So we can get a glimpse of how to work with the code cell hashes in the cell objects. So this is the resulting cell, the code cell of the build process.
Mhm.
And what we're gonna have here, I'll just put a console. The way we usually represent it is with base 64. All right, and now we build. Let's see that we get some kind of code cell hash. Okay, cool. So we have this, all right?
Mhm.
Now let's try to deploy. I expect it to have, let me pass in some funds into it. Good thing that Tony is so fast, right?
Yeah, indeed.
Okay, so I sent some Ton, something like 6 seconds, right? Hopefully. Not yet. Okay. So now it says it's already deployed because that's true. Okay, so it's not gonna deploy it. So I just want to take the address, the resulting address,
Mhm.
reminding that the resulting address is, what you get out of the initial data cell and the code cell.
Mhm.
So we have that. Okay, we have the contract as you see, probably on GitHub, the Ton starter template. So if you're not familiar with it, it allows you to withdraw some money, deposit some money, and to increment the counter.
Yeah.
Okay, also to transfer the ownership. So what I want to do now is to make changes in the code such that the resulting code cell hash would be different. So again, the code cell hash that we have is this, okay? Try to
Mhm.
remember this part. Now let's do some stuff, okay? Let's say that we change the name of this getter, okay?
Mhm.
For example, this, we see we get a completely different hash, right?
Yeah. Yeah.
That's good. If we return something different, again, a completely different hash, which is good. Now we will try some different things. For example, what happens if we modify a method that's not a getter? So let's, instead of calling this withdraw, let's call this something, right?
Mhm.
Let's try to be a bit of a cheaters. Okay. Same code as before, okay?
But why? Mhm.
So the reason is, it all depends on what the fancy compiler does with the code and how it gets turned into bytecode, because the code cell hash is a representation of the bytecode. So
Mhm.
obviously what we see here is that naming functions don't affect the resulting bytecode.
Okay.
This
Yeah.
is important because, people can change stuff, and you would think that the function does something just because it's named that way.
Yeah. Yeah.
In
That's where even
reality,
social engineering could be get into play.
exactly. In reality, you would need to, to be very careful and see that the code does what it claims to be doing. but at least you have that code. I mean, you can download it and build tests upon it, and whatever you want.
Mhm.
Because even if someone tries to cheat and you do a deposit instead of a withdraw, you would see it because you would have some kind of expectation on that code path. So that part is important to understand.
Mhm.
Obviously, comments, same thing. Okay, handle bounce message. So it's not handle bounce message.
Mhm.
Okay, and this is the code that I upload now to the verifier, and you wouldn't know that. So
Mhm.
that's an important part. But let's say we do, I don't know, some kind of positive change. I mean, we're not trying to cheat, we're just upgrading the code in some way.
Mhm.
So I don't know, maybe we want to allow um strong access denied. You know what? We decided with that we don't want access denied to be 102 and we want it to be 401. Okay. Maybe it's a standard thing. So we make this kind of change. We now get a different code cell hash, right?
Yeah.
And now we want to upload this to the verifier. So first thing to do is to deploy the code on chain.
Mhm.
Okay. We're getting this resulting address, which is obviously different than before
Mhm.
because of the different code cell hash. It computes to different code. So now let's enter this address. Yeah, so it takes a while because not yet deployed, but now it does. Okay, so we have the code hash. Let's see that it matches what we had here. Yeah, seems the same, right? I4Q and
Mhm.
I4Q here as well. Now what I want to do is to take the code. So I take the main and the imports here.
Why were you able to add sources? Because you logged in with your Tonekeeper, whatever, right?
So actually, you need to be logged in order to run the compilation, against the backend. But it's not because I have a certain role. I mean, anyone can do it. You can verify the code if you want now. We kind of expect usually the contract developer to do it, but it's not mandatory. Anyone can do it. If you can provide the backend with the proof, I mean, with the source code that results to this contract's resulting code cell hash, then it's okay. It doesn't matter who does it.
Mhm.
Okay, so now I don't need this in the command because they're already included via the include directive. And
Mhm.
now I just compile it. Okay, and it says the backend says actually, the output hash matches this contract on chain. So what I do now is issuing a transaction. I need to fund the source item contract. So any verification costs about a half a ton. And now I go to my, for example, Tonekeeper wallet, and it shows me the transaction, which I confirm. Okay, so I'm gonna take. So what happens now is that I sent a message to the verifier registry.
Mhm.
It checks the signatures. Okay, it passes them on to the source registry, which passes it on to the deployment of a new contract, which holds the link to the IPFS that describes this contract. Okay, so now if I do a view verified contract, we have that, and let's see that we have that 401 that we had. Okay,
Mm.
so this is the source code, that we changed a bit, but it changed a lot because it's a different code hash completely.
Mhm.
And I want to show maybe the flow here, okay? Because we can see both the verifier registry and the sources registry. So let's go to Tone Scan. And we have the transaction that we made, okay? This is my wallet.
Mhm.
And it issued a transaction into the verifier registry, which is this one. And verifier registry went to continue to the sources registry. Okay, so sources registry is this one, the NL1, as you see here, and it issued a transaction to the new one, which is this contract. Okay, so this is a contract that holds it's called the source item contract. That's what we call it, and it holds the link to the IPFS that describes the contract. So if I take the address of the source item contract and take it to verifier, for example, since I've already uploaded a proof for one of them, I can now view all of them, right? Because they all the source item contracts share the same code cell hash.
Yeah.
And what you can see is what it does, which is not that much. It has this important get source item data. And what we want from here is the content, and the content is the pointer to the IPFS. Okay.
Nice.
Same thing we can do, for example, for the source registry. We can also view it. Okay. So, for example, this is the deploy source item part, which is, it works kind of like a minter in Gtons.
This is what I also liked. Another part, it's about this kind of ready for sharding architecture.
Yeah.
So we don't have fat dicts with a lot of addresses of new contracts, not scalable contract of the sources.
Yeah. This is crucial in Ton because we're expecting to have like many contracts with different code, obviously. So that part is important. And
It also makes very much like this is like it just hits me logically that what you just said is that you will have a same code cell hash, even though this is like thousands of contracts that are doing the same thing, that are just like child contracts, let's say, and they're doing the same thing, so we don't need to re-verify them. It's just
yeah,
cool.
exactly. Yeah, so the important thing is that we've done like extensive work with both the foundation and Tonscan, for example, to really cover a large amount of contracts. So I think in terms of the amount of contracts themselves, we're probably covering like 80% now of what exists. So there's probably like a long tail of things we don't know, but all these DNS and NFT and Gtons, so most of them are already covered here. And obviously we encourage anyone to publish their source code to this platform. Yeah, I think that's it.
Can I ask a question? So basically, if I'm going to take, so let's say Get Jams have their contract for NFT collection, and I just take their contract as it is, I'm going to be verified automatically because the code cell hash is not going to change, right?
Yeah, exactly. It's the same here. It's like it's exactly the same as the source item that we saw. So if you take, for example, a Gton, which is, I think, the same use case. If we take any Gton that's deployed, we're gonna be able. Oh, sorry. We're gonna be able to view its source code. We're gonna know it's a Gton minter. So same thing.
Nice. Man,
Uh,
I kind of I'm so now satisfied to see that because Tal was talking about this on the interview, and it was kind of sitting in my mind all this time.
yeah.
I'm not that of a level to propose solutions, but my head is always like trying to generate one, And right now it's just like got released because I believe this is very solid, man. I like it in so many ways, and wow, I feel like a lucky guy who got explanation on that just directly from you, and that's why I'm so much appreciate that for that you actually take some efforts to bring this to us, like because this is going for everyone. This is so cool that everyone now can kind of consume that and understand it and think about it like in quiet time.
Yeah,
Wow.
yeah. I think it's important, for the Ton community and ecosystem, it's important that we do these things early enough, so that it becomes the standard, and hopefully all contracts on Ton will share this.
Hmm. Hmm. Wow. Yeah. So like maybe a quick question, what kind of what kind of links we should share like in the description, so I would
Um,
outline it for guys now.
Yeah, sure. So I think, yeah, we can share a link to the tool itself, the tonverify.live tool. We can share a blog post about the announcement that we've made, also to the tab that describes the solution.
Hmm.
That could be good too.
What about SDK?
Oh, yeah, yeah, good point. So we have the contract verifier SDK. That's quite simple. It allows anyone to get code highlighting for Fund C and Fifth. And it also, does the heavy lifting of querying the contract. So I can show a very quick demonstration of it. One
Mhm.
second. Okay. So we have, let's show the example project first. Okay, so we have just, a very minimal example project that shows you that you can integrate this UI.
Mhm.
It, supports UI modifications such as showing the line numbers or not even showing the files if you want a different UI for that.
Yeah.
Uh, so this is the UI part of the SDK. And also important to mention, the way you use it, which is if we take the example here. So it just does a get sources data. Sorry, it does a get sources JSON URL, which returns the IPFS link in case it exists. So here it's only providing the code cell hash for which it's trying to query. It can also provide the verifier ID.
Mhm.
Okay. And then when you do have the IPFS link, you can get the sources data and then just feed it to the UI. So it's very simple thing. You can either use it directly or as a reference implementation if you have your own product that you want, to have more customization options.
Okay.
But this is a good, I think it's a good link to put so people can see how we load the data in practice. Okay.
Okay. Okay.
Um,
Sure. I'm going to put it into description as well.
yeah. Cool. So I think yeah, that should cover it.
Man, I want to just maybe I repeat myself, but I want to give you two big thanks. One is that you and your team, Orbs team, you guys working on that. Like people like me who are like on a quite a not very high level of programming, we can claim we're building for next billion users, but people like you and the team like yours, you guys are actually making it very like possible to happen. And another big thank you for having us here with this time. Like, thanks for spending this time with
Yeah,
us.
sure.
And
Thank you for having me and giving the stage to the solution.
man, my pleasure. I really enjoy that, and I hope that our subscribers, we all hope that we're gonna see you here again, man. This
Thank
would
you.
be super cool.
Thank
Yeah.
you, Marco.
All right. Ciao, ciao.
Bye bye.